Did you know that Indiana is home to a sand dune so immense, Mount Baldy, that it literally moves and has even swallowed entire trees in its silent advance? Or that the state boasts some of the largest limestone quarries on the planet, so vast that its stone has been used to build everything from skyscrapers to national monuments? And did you know that beneath your feet, Indiana hides a subterranean labyrinth of caves, rivers, and canyons so extensive that some areas remain unexplored? And I'll tell you just one thing, prepare yourself for what's coming, because Indiana is far more surprising and wild than you can imagine. And when we get to the final facts, you'll understand exactly what I mean. 50. Indiana contains more than 35,000 miles of rivers and streams. For a state often labeled as landlocked and quiet, Indiana hides an impressive web of flowing water. Those 35,000 miles include everything from major rivers like the Wabash to tiny creeks that twist around farms, forests, and small towns. To give you a sense of scale, if you stretch them end to end, they would wrap around the earth more than once. This dense network plays a key role in agriculture, habitats, and drainage patterns, especially in flat areas where rainfall needs somewhere to go. It also makes Indiana surprisingly rich in freshwater ecosystems. 49. The Wabash River is one of the longest entirely contained in a single U.S. state. The Wabash travels more than 475 miles from northeast Indiana to the southwest border, never leaving the state until it forms the boundary with Illinois. It is rare for a river of this length to remain within one state's borders for so long. Because of that, it influences a huge portion of Indiana's terrain, carving valleys, feeding tributaries, and creating natural corridors for wildlife. Its watershed covers large portions of the state, shaping soil fertility and settlement locations even today. 48. Indiana features one of the most diverse soil profiles in the Midwest. Many states in the region have consistent soil types, but Indiana is sliced into multiple geological zones featuring loess, clay, sandy glacial deposits, and rich silt. These differences were shaped by glaciers, rivers, and ancient lake beds. Northern Indiana's soil differs drastically from southern Indiana's, influencing everything from agriculture to vegetation. This variation helps explain why the state grows a wide range of crops, not just the iconic corn and soybeans people usually imagine. 47. The northern third of Indiana was shaped heavily by glaciers. During the last glacial period, massive ice sheets covered northern Indiana, leaving behind moraines, kettle lakes, and flat plains that remain visible in the landscape today. These glaciers sculpted the land by bulldozing soil and rock, flattening huge areas and creating the formations that now define the region. Because of this, northern Indiana has a very different topography than the hillier southern part. The evidence can be seen in lake clusters, smooth terrain, and the absence of deep valleys in the north. 46. Indiana contains one of the United States' largest limestone deposits. South Central Indiana is globally recognized for its limestone, but this fact is not about history or architecture. It's about geography. The stone lies in thick, extensive layers beneath the surface, created by ancient marine sediments. These limestone beds define the region's terrain, forming cliffs, sinkholes, rolling hills, and natural drainage systems. The rock is so abundant that entire counties rest on solid limestone foundations, giving southern Indiana a rugged appearance compared to the flatter northern regions. Before continuing, be sure to subscribe to discover hidden stories and curiosities about every U.S. state that no one else will tell you. 45. The state's tallest natural point, Hoosier Hill, reaches 1,257 feet. Hoosier Hill sits in the far eastern part of Indiana near the border with Ohio. Although its elevation is modest compared to mountainous states, it marks a distinct high point in a region often considered flat. The surrounding area gently slopes outward, making the rise subtle rather than dramatic. From a geographic standpoint, it represents the state's gradual tilt downward from east to west, a pattern that influences watershed movement and river flow directions. 44. Indiana's lowest point lies at the confluence of the Wabash and Ohio rivers. This location in the southwest corner of the state drops to about 320 feet above sea level. The contrast between Hoosier Hill and this lowest point creates a vertical relief of nearly 1,000 feet across the state. It is this downward slope that guides major river systems and affects everything from erosion to soil distribution. Even though Indiana lacks mountains, this gradient is significant enough to impact weather patterns and drainage behavior. 43. Indiana borders Lake Michigan with a shoreline of approximately 40 miles. Most people do not realize that Indiana touches one of the largest freshwater lakes on Earth. The state's slice of shoreline may be small, but its geographic influence is huge. Lake Michigan moderates temperatures in nearby counties, creates lake-effect weather, and supports unique dune ecosystems. The shoreline also provides habitats for fish, migratory birds, and dune-adapted plant species that are uncommon elsewhere in the state. 42. Indiana dunes feature some of the tallest freshwater dunes in the world. Along the southern edge of Lake Michigan, dunes climb up to 200 feet high. These dunes shift over time due to wind patterns, creating living landscapes that evolve slowly across centuries. The mixture of sand, vegetation, and lake breezes forms a rare ecological zone. Geographically, the dunes act as natural barriers and contain microclimates where temperature and moisture levels vary from one slope to another. This makes the region one of Indiana's most unique landforms. 41. Southern Indiana is dominated by karst landscapes. Karst terrain is created when water dissolves limestone, producing caves, sinkholes, natural bridges, and underground streams. Southern Indiana sits atop thick limestone beds that have eroded into a complex karst system. This type of landscape influences road construction, groundwater movement, and ecological patterns. It also results in natural drainage, meaning water often disappears underground rather than flowing across the surface, making the region drastically different from the glaciated north. 40. The Ohio River shapes much of Indiana's southern border. The river defines the state's entire southern boundary, stretching hundreds of miles. Its wide floodplain influences soil richness, agricultural suitability, and settlement patterns along the bottom half of the state. Geographically, the Ohio River provides one of the clearest examples of how water systems create natural borders, carving out valleys and supporting wetlands. Its presence contributes to the broader watershed that ultimately drains into the Mississippi River. 39. Indiana contains one of the largest hardwood forest areas in the Midwest. Though often associated with agriculture, about 1/5 of Indiana is forested, especially in the southern part. These forests consist of oak, hickory, beech, and maple species adapted to the region's varied soils and rolling hills. Forest distribution maps reveal that terrain plays a key role. Hilly areas with less agricultural suitability tend to remain wooded. This creates distinct ecological zones within the state and supports wildlife corridors that run through less developed regions. 38. Central Indiana sits on a noticeable geological transition zone. The state's middle region acts as a meeting point between glaciated plains to the north and rugged limestone landscapes to the south. This creates a varied mixture of terrain, gently rolling fields, river cuts, gravel deposits, and scattered hills. Because of this transition, central Indiana showcases multiple soil types within short distances, influencing farming, vegetation, and drainage patterns. It is one of the reasons the region does not appear uniformly flat despite common assumptions. 37. Indiana contains naturally occurring peat bogs and marshlands. Peat bogs are more commonly associated with northern climates, yet several exist in Indiana. These wetlands form in areas where drainage is poor and vegetation decomposes slowly, creating thick organic layers. Marshlands accompany them, especially near rivers and low-lying basins. These environments influence regional groundwater, support unique plant communities, and provide habitats for amphibians and birds that rely on saturated ecosystems. Their presence highlights the state's ecological diversity beyond farmland. 36. Brown County is one of the most topographically varied regions in Indiana. This area features steep ridges, narrow valleys, deep hollows, and densely forested hills. Its terrain stands out because glaciers never reach this far south, leaving the land untouched and rugged compared to the smooth northern half. Elevation changes are frequent and noticeable, making the region geographically distinct within the state. Brown County's landscape also demonstrates how unglaciated terrain tends to develop more dramatic topography over time. 35. Indiana has a rare divide between three major watersheds. Several drainage divides run through the state, sending water toward the Mississippi River, Lake Erie, and the Ohio River. These divides determine where rainfall eventually ends up, creating hydrological distinctions across counties. Even small elevation changes can redirect entire water systems. The presence of three major drainage paths highlights Indiana's central location in North America's broader watershed network, connecting the state to distant river systems and lakes. 34. Northern Indiana contains clusters of kettle lakes formed by glaciers. These lakes were created when retreating glaciers left behind buried ice blocks. Once those ice blocks melted, the ground above them collapsed, forming basins that filled with water. Kettle lakes tend to be round, relatively deep, and scattered irregularly across the landscape. They contribute to northern Indiana's water-rich geography, support diverse aquatic ecosystems, and demonstrate clear evidence of the glacial processes that once shaped the region. 33. Indiana contains sandy lake plains that stretch far inland. People usually assume sandy terrain is found only along the Indiana dunes, but wind and glacial activity push sand far beyond the shoreline. These sandy plains extend miles inland, creating soil conditions that differ sharply from surrounding farmland. This type of terrain drains quickly, supports certain vegetation better than others, and leads to micro-landscapes that resemble miniature inland deserts. These sandy patches are remnants of ancient lake fluctuations and glacial deposits, providing strong geological evidence of how dynamic the region once was. 32. The Tipton-Till Plain covers a huge portion of central Indiana. This region is named for the thick layers of glacial till left behind after ice sheets receded. The plain stretches across many counties and is known for its nearly level terrain with slight, broad undulations. The soils here are rich, well mixed, and ideal for agriculture because glaciers deposited a blend of materials from distant areas. The uniformity of this plain also makes it distinctive. You can travel long distances without dramatic elevation changes, yet the land remains productive and varied beneath the surface. 31. Indiana contains one of the largest concentrations of sinkholes in the Midwest. Most of these sinkholes are located in the limestone-rich southern counties where karst systems dominate. Sinkholes form when underground cavities collapse, which happens naturally over long periods. While not all are dramatic or easily visible from afar, thousands are mapped across the region. This high concentration tells geographers that groundwater has been dissolving rock beneath the surface for ages, carving hidden channels that influence surface stability, drainage behavior, and even how communities plan development. 30. The White River system divides Indiana's interior terrain. The West Fork and East Fork of the White River flow through large portions of the state, carving wide valleys and shaping the distribution of towns and farmland. These rivers create fertile floodplains that contrast with the higher, flatter plains around them. The system acts as a major drainage corridor, collecting runoff from central Indiana and channeling it southward. The branching pattern of these rivers provides a clear illustration of how waterways organize the land, guiding both natural and human movement. 29. Indiana has unique prairie remnants in its northwest corner. Although much of the state is now farmland, patches of original tallgrass prairie survive. These remnants appear in areas where soil and drainage conditions prevented full conversion to agriculture. The geography of the northwest corner once supported expansive prairies similar to those of Illinois, and these surviving segments showcase what the region's landscape looked like before widespread modification. Their presence reveals that Indiana's natural environments were far more diverse than the typical image of endless cornfields suggests. 28. Southern Indiana's hill country includes deeply carved stream valleys. The southern third of the state features numerous narrow valleys created by streams cutting through soft bedrock and soil over thousands of years. These valleys form steep sides, twisting channels, and layered slopes that contrast dramatically with the flat northern plains. Because of the rugged terrain, forests dominate these areas, and development tends to follow ridge lines rather than valley floors. This kind of topography demonstrates how unglaciated landscapes evolve through natural erosion instead of being flattened by ice. 27. Lake Monroe is Indiana's largest entirely in-state reservoir by surface area. Although artificial, its geography plays a major role in shaping the surrounding environment. Built by damming Salt Creek, the reservoir occupies a broad valley and backs up into coves, arms, and wooded hills. Its creation formed new aquatic and shoreline habitats, altered drainage patterns, and changed the microclimate of nearby areas through increased humidity. The combination of rolling hills and a large expanse of water makes the region visually distinct from other parts of southern Indiana. 26. The Knobstone Escarpment creates some of Indiana's most dramatic relief. This natural escarpment forms along rugged ridge that rises sharply from surrounding terrain. It is composed of erosion-resistant bedrock layers that have remained intact while softer materials around them have worn away. The result is a line of steep hills and narrow ridges, giving this region the highest relief in the state. For geographers, the escarpment is significant because it shows how differential erosion shapes landscapes, creating striking terrain without the presence of mountains. 25. Indiana's far southwestern counties lie within a distinct river floodplain system. This region near the confluence of major rivers features broad, flat floodplains with soils that are extremely fertile but prone to seasonal inundation. The land is shaped by centuries of natural flooding that deposited nutrient-rich sediments. Because the area is low-lying, water movement is slower, and wetlands form easily. These conditions result in a landscape that differs from the rolling hills farther east, illustrating how river behavior strongly influences terrain. 24. Lake Michigan's influence extends deep into northern Indiana's climate and geography. Even though the shoreline is relatively short, Lake Michigan's presence creates temperature moderation, extra snowfall, and unique wind patterns. The lake affects snowfall seen in certain counties as a direct result of cold air passing over warmer lake water, picking up moisture and releasing it inland. This process shapes vegetation, soil moisture levels, and even the timing of seasonal changes. It is a perfect example of how a large body of fresh water can reshape an entire regional environment. 23. The Maumee River Basin in the northeast drains toward the Great Lakes. Unlike much of Indiana, which drains toward the Mississippi River system, the northeast corner sends its water to Lake Erie. This creates distinct drainage zones, soil types, and groundwater flow patterns. The geographic divide between watersheds means rainfall in one part of Indiana may eventually travel hundreds of miles in a completely different direction than rainfall just a few counties away. This dual drainage identity makes Indiana a unique hydrological crossroads. 22. Indiana contains numerous natural lakes formed by glacial action. While not as lake-dense as neighboring Michigan, northern Indiana still hosts dozens of natural lakes with glacial origins. These lakes vary in depth, clarity, and size, depending on how ice sheets moved and melted. Many are kettle lakes, but others formed from ice gouging, moraine damming, or sediment blockage. Their distribution highlights the power of glacial processes and explains why northern Indiana has a more water-rich landscape than the rest of the state. 21. The Ohio River Valley includes notable terraces marking ancient water levels. These terraces appear as step-like landforms along the valley walls, representing older floodplain surfaces left behind as the river gradually cut deeper into the earth. They provide visible evidence of how the valley evolved over long periods through erosion and sediment deposition. Terraces affect soil patterns and determine where communities could build safely above high water levels. In geographical terms, they offer a clear timeline of how the river carved its path. 20. Indiana contains isolated sand and gravel ridges known as eskers. Eskers are long, winding ridges created by streams flowing through tunnels beneath glaciers. As the glaciers melted, the sediment dropped and formed snake-like ridges that trace the path of ancient subglacial rivers. These features exist in parts of northern Indiana and stand out against surrounding farmland. They reveal how water moved beneath the ice sheets and how glacial meltwater shaped the terrain in intricate ways that remain visible today. 19. The state includes numerous shallow depressional wetlands called potholes. These wetlands formed from uneven glacial deposits and poor drainage in flat terrain. They fill with water seasonally or year-round, depending on precipitation. Potholes support specific ecosystems and indicate areas where glaciers left behind hummocky surfaces that never fully leveled. Their patterns help geographers understand how ice retreat influenced landforms and why certain areas remain wetter or less suitable for agriculture. 18. Indiana's upland areas create subtle rain shadow effects. While the state does not contain tall mountains, some upland regions, especially in the south, slightly deflect air masses and influence precipitation patterns. Areas on the leeward sides of hills may receive slightly less rainfall, while windward slopes gather more moisture. These differences, though modest, influence vegetation types, soil moisture, and local microclimates. They show that even small elevation changes can alter weather behavior across a landscape. 17. The northern counties include ridge and swale topography from ancient lake levels near Lake Michigan, Repeating patterns of narrow ridges and shallow troughs line the landscape. These formations were created as ancient shorelines shifted and lake levels rose or fell, leaving behind alternating bands of higher and lower ground. This topography influences drainage, soil distribution, and plant communities. The distinct parallel ridges provide strong geographical proof of how large bodies of water continually reshape surrounding land, even far from the present-day shoreline. 16. Indiana has multiple moraines that form natural arcs across the northern half of the state. Moraines are ridges formed from glacial debris deposited when ice sheets advanced or retreated. In northern Indiana, several prominent moraines sweep across the landscape in curved shapes, almost like someone gently drew giant arcs across the land. These ridges can rise noticeably above the surrounding plains, affecting drainage patterns and soil composition. Moraines typically contain a mix of clay, sand, gravel, and boulders, creating uneven terrain. Because these materials differ from nearby soils, the vegetation and agricultural potential often shift when crossing over one of these ridges. Moraines also help geographers trace the historical movement of glaciers by marking their former boundaries in the terrain. 15. Indiana's southern boundary follows the intricate bends of the Ohio River. While many state borders follow straight lines, Indiana's southern edge has a naturally formed, winding shape dictated entirely by the Ohio River's course. This creates varied shoreline shapes, oxbows, wetland pockets, and wide floodplains. And these contours have consequences beyond drawing a map. The river's twists influence erosion patterns, sediment deposits, and how bottomland forests develop. Some areas along this boundary are low and prone to seasonal flooding, while others rise sharply into bluffs that overlook the water. This mix of elevations and river-driven processes makes the southern edge of the state geographically dynamic and constantly evolving. 14. The Kankakee River once supported one of North America's largest inland wetland systems. Before large-scale drainage efforts reshaped it, the Kankakee Marsh covered immense portions of northwest Indiana. From a purely geographical standpoint, this was a vast, slow-moving water system shaped by glacial meltwater, shallow gradients, and poorly drained soils. The marsh's remnants still affect the region's modern landscape, determining soil types, groundwater movement, and the presence of isolated wetland pockets. Even though much of the marsh has been converted to farmland, its geological history remains stamped into the land, explaining why the northwest corner contains some of Indiana's most fertile and moisture-rich soils. 13. The Wabash Valley Fault System influences the southwestern region's geology. While not known for major earthquakes, Indiana does contain subtle fault lines linked to broader Midwestern tectonic structures. In southwestern Indiana, the Wabash Valley Fault System shapes subsurface formations and creates slight variations in bedrock depth and surface topography. Although the movements are minor, they have helped create natural zones of fractured bedrock, where drainage and soil development behave differently from surrounding areas. Geologists use these features to understand how ancient tectonic processes helped shape Indiana's deeper geological layers. 12. Indiana's terrain transitions gradually from northern plains to southern hills. One of the state's most interesting geographical characteristics is how smoothly the landscape changes from one region to another. In the north, agriculture-friendly plains dominate. Moving southward, the land begins to undulate, gently at first and then more dramatically as one enters unglaciated territory. This gradual change, occurring over many miles, creates a continuous transformation rather than abrupt differences. These transitions explain why the state contains both highly productive farmland and rugged hill country within a relatively compact area. It also means that Indiana's ecosystems shift subtly but steadily as you travel from one end to the other. 11. Indiana features buried bedrock valleys formed long before modern rivers existed. Deep beneath the surface, ancient valleys, carved by prehistoric rivers, lie filled with sediments left from glacial and post-glacial processes. These hidden valleys often run in directions that do not match today's river systems, showing that the landscape once drained differently. They influence groundwater flow and create zones where aquifers are thicker or more productive. Because the bedrock valleys vary in width and depth, they add an unseen layer of complexity to Indiana's subsurface geography. Scientists map them to understand water availability and geological history. Before we get to the 10 facts that corroborate what I told you at the beginning, remember to subscribe to the channel and give it a like to become experts in American geography. 10. The state contains multiple aquifer systems that differ sharply by region. Northern Indiana's aquifers are typically glacial in origin, composed of sand and gravel that store and transmit water efficiently. Central Indiana has mixed aquifers influenced by glacial till and buried valleys. Southern Indiana often relies on karst aquifers, where water moves through fractured limestone and underground channels. These differences mean groundwater behaves very differently across the state. In some counties, water flows rapidly through permeable sediments, while in others it moves slowly through dense bedrock. This diversity makes Indiana a useful model for studying how geology affects underground water resources. 9. Indiana has notable wind-shaped landforms that reveal past climate conditions. In certain regions, especially in the north, wind-deposited materials known as loess accumulate in thick layers. Loess consists of fine-grained dust carried by strong winds during colder, drier periods. When deposited, it forms soft, highly fertile soils that are easy to cultivate. Other areas contain wind-shaped dunes far inland from the present Lake Michigan shoreline, evidence that prevailing winds once carried sand across open landscapes. These wind-based deposits highlight how climate patterns have shifted dramatically over thousands of years, leaving visible marks on the terrain. 8. The Muscatatuck Plateau forms a distinctive landscape in southeastern Indiana. This plateau is characterized by dissected uplands, meaning water and erosion have carved deep valleys and ridges into the elevated terrain. The plateau's surface consists of erosion-resistant rock layers that create a rugged, broken appearance. This topography influences where forests grow, how streams behave, and where roads can be built. The landscape's irregular nature makes it distinct from the flatter plains to the north and the softer hills elsewhere in southern Indiana. Its geological complexity showcases how resistant rock formations shape land even without glacial influence. 7. Indiana hosts numerous spring-fed streams with uniquely stable temperatures. These streams originate from underground sources where water maintains consistent temperatures throughout the year. When the water emerges, it creates environments ideal for specific plants and aquatic species. Spring-fed streams tend to be clearer because the water filters through rock and soil before surfacing. Their steady flow also shapes distinctive stream channels, often with gravel or rocky bottoms rather than muddy ones. These features illustrate how groundwater systems influence surface ecosystems and contribute to the state's aquatic diversity. 6. The driftless area touches a small part of far south-central Indiana. Although most of Indiana was either glaciated or influenced by glacial deposits, a tiny portion of its south-central region shows characteristics similar to the driftless area of neighboring states. This means the land was never flattened or reshaped by glaciers, leaving older erosional features intact. Here, ridges, steep slopes, and narrow valleys dominate, offering a glimpse of what more of Indiana might have looked like if ice sheets had not overridden most of the state. This pocket of ruggedness contributes to southern Indiana's overall topographical variety. 5. The Patoka River Basin supports one of the state's most complex wetland networks. The basin spreads across southwestern Indiana and includes broad floodplains, oxbows, backwaters, and interconnected marsh systems. Its geography makes it one of the most water-rich environments in the state. The slow-moving nature of the river and its low-lying surroundings allow water to settle and create wetlands that host a wide variety of plant and animal species. Because the basin includes both open water and heavily vegetated swamp areas, it displays how river basins can develop intricate patterns when gradients are gentle and sediment flows are steady. 4. Indiana's glacial outwash plains show how meltwater built the modern landscape. Outwash plains occur where glacial meltwater deposited sand and gravel in broad sheets. These plains can be found in various parts of the state, especially near former glacier boundaries. Their soils are often highly porous, leading to fast drainage and distinctive vegetation patterns. The flatness of these plains contrasts with nearby moraines, giving certain regions a layered look. Ridge, plain, ridge, plain. These alternating landforms are evidence of how glaciers advanced and retreated multiple times, leaving behind a sequence of deposits that define today's landscape. 3. The state's interior contains numerous interlobate regions where glaciers collided. Interlobate zones form where two glacier lobes pressed against each other, depositing thick layers of mixed sediments. These areas often contain highly varied terrain, including steep hills, ridges, ponds, and irregular depressions. In Indiana, such regions appear in parts of the north and central portions of the state. Because of their complexity, interlobate regions support diversity diverse ecosystems and varied soils within short distances. They are prime examples of how glacial interactions created landscapes far more intricate than simple plains. 2. Indiana holds one of the Midwest's most extensive underground river networks in karst areas. Southern Indiana's karst terrain contains countless underground channels where water flows invisibly beneath the surface. These underground rivers range from small trickles to significant waterways moving through caves, fractures, and dissolved limestone passages. Surface streams sometimes vanish into sinkholes, reappearing miles away. This hidden hydrological system reshapes the land by creating voids that eventually collapse, forming sinkholes or altering surface drainage. It highlights how water can sculpt landscapes not only above ground, but deep within the earth. 1. Indiana's geography blends glacial, fluvial, karst, and upland systems into one seamlessly varied state. Unlike states dominated by a single landform type, Indiana is a mosaic of distinct geographical systems. Glaciers sculpted the north into plains and lake-filled basins. Rivers carved valleys throughout the center and south. Limestone dissolved to create caves and sinkholes. Elevated ridges and plateaus shaped microclimates and vegetation zones. All these elements intersect, producing a state where subtle differences accumulate into a surprisingly rich geographic tapestry. Indiana's landforms demonstrate how different natural forces can coexist and merge, producing a landscape far more diverse than most people realize when they glance at a map. Indiana's geography often hides behind simple stereotypes, yet the land tells a much more intricate story. The state blends glacial legacies, river-shaped valleys, rugged unglaciated hills, freshwater dune systems, underground rivers, rich soils, and multiple watershed divides. The result is a landscape full of geological clues, ecological patterns, and subtle variations that reveal its complexity to anyone who takes the time to explore it closely. Whether you look beneath the surface, follow the rivers, examine the soils, or trace the ancient movements of ice and water, Indiana stands out as a state shaped by many forces working together. Now that you know these 50 facts about Indiana, tell us, which one did you like the most, or which one surprised you the most? We'd love to read your opinion in the comments and see how many of us picked the same number. And something else many of us will probably agree on is watching the video I'm leaving on screen, because we all love sharing and learning interesting facts. And that's exactly what this video is all about. But before you watch it, don't forget to subscribe to the channel and